the end of the session. But today I want to conclude a very important topic, that is alkalinity. Okay. So heading of this topic is alkalinity. Hope you remember when I was discussing about the problems that are caused due to dissolved salts in water. I talked about the hardness. The other one is alkalinity. Okay, and this is a very interesting topic. Okay, and what I want to tell you all is listen to the lecture with lot of concentration. Okay, you'll enjoy the session, and you will at once okay, at once you will feel that you have understood the topic. That's the idea. Okay, so right now this has got stuck. That's a problem. Okay, so write the heading alkalinity, and what the name tells, that I'm taking water sample, and that water sample is having lots of dissolved salts present in it, and it is having another problem called as alkalinity. Okay, the definition is, you can take along with me. I'll give an overview. Okay, so what is the definition? Acid neutralizing capability. Acid neutralizing capability of water is called alkalinity. Acid neutralizing capability of water is called as alkalinity. Okay, ఏం చెప్పా alkalinity అంటే ఏంటి? ఇది కూడా ఒక ప్రాబ్లం encountered due to dissolved salts present in a sample of water. Okay, ఈ dissolved salts ఉండడం వలన ఏమవుతుంది? A particular water sample alkalinity అనే ప్రాబ్లం తో సఫర్ అవుతుంది. alkalinity ప్రాబ్లం ఏంటి అంటే, hope you remember when I was talking to you all about the fluorosis problem in Nalgonda district. Okay, then I told you all it is a geogenic problem. It means what? It is a natural phenomenon. No one is polluting water, but the problem is due to the natural conditions. Why? I told you already that there is granite ore in Nalgonda district. Okay, and one of the component is calcium fluoride. Okay, so what will happen when the groundwater is in touch with that ore? Because of lot of concentration of OH minus ions, carbonate ions, bicarbonate ions, fluoride ions, what will happen? The ore quickly starts exchanging fluoride ion into the water, and it will take the OH minus or the carbonate, bicarbonate ions from the water. Okay, greater the concentration of water, greater is the reaction of the groundwater with that ore, and greater is the leaching of the fluoride ions, leading to the problem. Okay, so this problem is also very, very important. We should study that. Okay, and I told with you that though there is no hardness much impacted due to sodium chloride in seawater, but still can we use seawater for construction purpose or any other purpose? No. Why? Because it may not possess hardness, but it possesses another problem called as alkalinity. Okay, which leads to quick corrosion of the material. We have seen in corrosion topic, neutral or slightly alkaline medium is one which actually supports lot of corrosion. Okay, particularly ships that are moving in seawater. Okay, So this problem of water should also be studied in a very serious way. Okay, and it is defined as the acid neutralizing capacity of water. Now, can anyone tell me? I'm talking about what type of titration? Alkalinity, acid neutralizing capability. So what type of titration I am talking about? It is an acid-base titration. Okay. So before I say about that, I'll say the next point. The first point is the definition. What's the second point? Ions which cause alkalinity. Ions which cause alkalinity are, first ion is OH minus, the second ion is CO3 2 minus, and third ion is HCO3 minus. These are the ions which contribute to alkalinity to a major extent. Apart from that, silicates, borates, phosphates also contribute to alkalinity. Okay, so in chapter now, okay, what you have said, these contribute maximum. Okay, they contribute maximum. Okay, but there are other ions which are borates, silicates, phosphates, etc., like sulfates, etc. These contribute to less. This concentration is also less, and they contribute to less alkalinity. Therefore, we are not considering them. Okay. So, is the discussion. In chapter, aim asal sare alkalinity of water dissolved salts valana vastundi. Baundi. అయితే ఏం dissolved salts ఇస్తాయి అంటే, alkalinity of water గురించి ఎప్పుడైనా డిస్కస్ చేస్తే నేను 3 major ions గురించి చెప్తున్నా. Okay, so these are the 3 major ions. Okay, and whenever you are talking about alkalinity, you are talking about the anionic concentration of these 3 ions. So what is the third point? Alkalinity, estimation of alkalinity. Estimation of alkalinity is finding the concentration of the above 3 anions. Above 3 anions by acid-base titration. By acid-base titration. That's the major one. So, in Japan, what I'm saying, when I'm saying that I'm finding the alkalinity of a particular sample of water, then I'm talking about finding the concentration of this OH minus, HCO3 2 minus, and HCO3 minus ions. Who is this Sri Vishnu? Okay. I'm talking about the concentration of OH minus, CO3 2 minus, HCO3 minus ions only. You understand? That's what it is. Fine. So this is an acid-base titration. Okay, because my test sample is alkaline in nature, and I am reacting that alkaline test sample with an acid whose concentration I already know. So it's an acid-base titration. That's the first point. And when I'm saying I'm finding the alkalinity of that water, then it means I'm finding concentration of these 3 anions. So what are the 3 anions? OH minus, carbonate, and bicarbonate. Okay. So by this time you might have already understood that if a salt, whether it is sodium bicarbonate or sodium carbonate, potassium bicarbonate, potassium carbonate, any of these things will lead to alkalinity of water, along with calcium carbonate, magnesium carbonate, calcium bicarbonate, magnesium bicarbonate, like that. So these hardness causing salts also contribute to alkalinity of water because they are associated with these three anions. Okay, so that's the third point. Hope everyone is catching it. Fine. So what's the fourth point I'd like to tell is, fine, in this experiment, because I'm doing an acid-base titration, okay, so what is the fourth thing I need to explain to you all is that I'll use indicators, okay, I'll use indicators. Now, what are the acid-base indicators that I'm using? So, this quantitative analysis is by acid-base titration. Acid-base titration. Quantitative analysis is by acid-base titration. Okay. By acid-base titration. Fine. Now, what's the second point I need to tell you is, okay, fifth point. Two indicators, two acid-base indicators are used in the titration. This is important point. Okay. Two acid-base indicators. Two acid-base indicators are used. Okay. Two acid-base indicators are used. What is the first acid-base indicator I am using? Is the first one is methyl orange indicator. The first indicator I am using methyl orange indicator. Okay, methyl orange indicator. This indicator, methyl orange indicator. So the other one is, leave some space and write. Second one, phenolphthalein indicator. Phenolphthalein. The other one is phenolphthalein indicator. Phenolphthalein indicator. Okay. So there are two indicators I am using in the experiment. One is methyl orange indicator. The other one is phenolphthalein indicator. Both the indicators are used for the same titration. That's the beauty of this experiment. Okay. So before I proceed ahead, I need to tell you about this methyl orange indicator. Okay. This methyl orange indicator is one indicator which is actually an indicator having pH range. Its pH range is from 3.1 to 4.4. 3.1 to 4.4. Its pH range is 3.1 to 4.4. That's the first point I have to tell. Okay. Then color change is okay, red in acidic medium. It is red color in acidic medium and yellow in basic medium. Yellow in basic medium. Yellow in basic medium. Okay. Are you able to see the board? Next point. It can detect all the three anions. What's the next point? It can detect all the three anions. That is OH minus, carbonate CO3 2 minus, and HCO3 minus. So it can detect all the three anions. Okay, that's the next point. So what's the, hope you are able to see the board. Okay, in chapter alkalinity estimation. What is alkalinity? It is the acid neutralizing capability of water. Okay, then if I'm saying that I'm finding the alkalinity of the sample, test sample, then I'm finding the concentration of OH minus, carbonate and bicarbonate anions, okay, which cause alkalinity of water. So the second point which I wrote was ions which cause alkalinity are OH minus, carbonate and bicarbonate, and these are generally present in maximum ratio. There are other ions like the borates, silicates, phosphates also contribute to alkalinity, but I will not discuss much about them because they are present in very less concentration. So I'll not much bother about it. Okay. Next, I want to do estimation of alkalinity of water. So if I'm doing an estimation of alkalinity, then I'm finding the concentration of these three anions, that is OH minus, carbonate and bicarbonate. And the titration I do is an acid-base titration. So quantitative analysis is by an acid-base titration. Okay, that's the next one. After that, because I'm doing an acid-base titration, it is nothing but neutralization. So what is neutralization? Reaction of an acid with a base. Okay, that's the most important one. Or H plus ion from acid will be reacting with the anion of the base to form salt plus water. That's a main reaction. So here I am using indicators. Obviously, water is colorless, and the acids like HCl or sulfuric acid that are used for finding the concentration of the water sample are also colorless. Because both the reagents are colorless, I am using a indicator. So what are indicators? These are the substances that are added in small proportions to the reaction medium, but they show color change due to change in the reaction conditions. Ante ఏంటి acidic medium లో ఒక కలర్, basic medium లో ఇంకో కలర్ చూపిస్తాయి. And they indicate the end of the titration. So the two indicators that are used are methyl orange and phenolphthalein. Okay, for my importance or discussion, I've started with that of methyl orange, a very excellent indicator. It has pH range from 3.1 to 4.4. ante meaning enti, ee indicator shows color change within this range. Okay, how? I'll tell. See here, I was like telling you that it is red in color in acidic medium, yellow in color in basic medium. Okay, that means what? If the pH is less than 3.1, it is red in color. Okay, if the pH is more than 4.4, it shows yellow color. That's it. Okay, though the range is acidic, but for that indicator, when it falls beyond 4.4, it turns yellow in color. Okay, and is the discussion. Fine. So the color change of the indicator is red to yellow or yellow to red. Red in acidic medium, yellow in basic medium. Okay. So what is the color of the indicator in between 3.1 to 4.4? It is hue color. Ante red and yellow ki combination. Mixed color lo untunda indicator. Otherwise, less than 3 అయితే అది రెడ్ కలర్ లో, any pH above 4.4 ఉంటే అది yellow color లో ఉంటుంది. So is the indicator. And because of this pH range, this particular indicator can detect all the three anions. What are those three anions? OH minus, carbonate, and bicarbonate. Okay. Before I start talking about the phenolphthalein indicator, I need to tell you all. Out of these three anions, which are stronger anions and which is the weaker anion? Out of these three anions, which are strong and which are weak? ఏంటి ఏదో క్లాస్ అటెండ్ అవుతున్నావు అని అయ్యో లబోదిబో అనుకుంటే మళ్ళీ క్వశ్చన్స్ కూడా ఏంటి మ్యామ్ అంటే లేకపోతే నీకు బోర్ కొడుతుంది. నా బాధ అది. నీకు బోర్ కొట్టకుండా క్లాస్ చెప్పాలి కదా నేను. రోల్ నెంబర్ 62, 61, 71, 72. అయ్యా అందరూ అబ్సెంటేనా? 81, 82, 91, 92. What is this?
OH
Nobody is
minus.
present. Huh?
OH minus.
Try your roll number 92.
Ma'am, OH minus.
Is strong and is carbonate, whereas bicarbonate is a weaker anion. Okay, that's what I want to tell. Okay, so is the discussion. Now what I'll do, I'll rub the board and write about the phenolphthalein, the second indicator. Okay, phenolphthalein, the second indicator. So next one is phenolphthalein. Neeraj, is anyone with names Sri Vishnu in your class? Sri Vishnu అని ఎవరన్నా ఉన్నారా? ఏంటి?
No ma'am.
నీరజ్ డాన్స్ చేసి వెళ్ళిపోయాడా హాయిగా సినిమా చూడటానికి? ఉన్నాడా? I'll get back. There's no time for me now. The next indicator is phenolphthalein. Okay. Now, what is this phenolphthalein indicator? It's an indicator which has pH range from almost it falls in the basic range. Okay, from 8.2 to 10. So this phenolphthalein indicator pH range is almost from 8.2 to 10. It means what? Below 8.2 it is colorless. Above 10 it is red in color or pink in color. That's a exact one I can say. So what is the color change of the indicator? This indicator, okay, so color change is colorless in acidic medium, and pink color in basic medium. Pink in basic medium means what? It is an indicator which works in a high pH range. Okay, so it is pink in color in basic medium. That's a color change of the indicator. So what's the color of the indicator? Less than 8.2, colorless. Above 10, it is pink in color. Okay, so what else it can detect? It detects only OH minus and carbonate ions which are strongly basic. It can detect only OH minus and carbonate ions which are strongly basic. So these strongly basic ions are also called as caustic ions. Why? Because the alkalinity they cause is caustic alkalinity. So detects only OH minus and carbonate which are strongly basic. OH minus is actually strongest. Carbonate is also reasonably not very strong. Strongly basic ions. Okay. So this is the main premise on which I am doing the experimentation. So what I'm saying, ఏం చెప్పా యాసిడ్ బేస్ టైట్రేషన్ చేస్తున్నాను. ఆ చేసే యాసిడ్ బేస్ టైట్రేషన్ లో ఏం చేస్తానంటే నా టెస్ట్ సొల్యూషన్ ఏమో బేసిక్ సొల్యూషన్ బికాస్ ఆల్కలైన్ కాబట్టి దాన్ని ఒక యాసిడ్ తో రియాక్ట్ చేస్తా. ఆ యాసిడ్ ఏమవ్వచ్చు, హెచ్సిఎల్, సల్ఫ్యూరిక్ యాసిడ్ అలాంటి యాసిడ్స్ అవ్వచ్చు. ఓకే, ఆ యాసిడ్ కాన్సన్ట్రేషన్ నాకు ఆల్రెడీ తెలుసు. సరే, యాసిడ్ కలర్లెస్, నా టెస్ట్ సొల్యూషన్ ఏదైతే బేసిక్ ఉందో అది కలర్లెస్ కాబట్టి ఇండికేటర్స్ వాడతా. ఈ ఎక్స్పెరిమెంట్ లో ఏంటి కొంచెం పెక్యులియారిటీ అంటే ఐ యూస్ 2 ఇండికేటర్స్ ఇన్ ఏ సింగిల్ గో. అంటే ఒకటే టైట్రేషన్ లో 2 ఇండికేటర్స్ ని వాడతా. ఓకే, సో ఈస్ ద స్పెషాలిటీ. Okay, what are those 2 indicators? Methyl orange, phenolphthalein. Excuse me. So first methyl orange గురించి చెప్పా. This is the methyl orange is an indicator which has the color change in acidic range. అంటే దాని pH range ఎంత, 3.1 to 4.4. అంటే it is an indicator more in the acidic range. Okay, then color change ఏంటి, రెడ్ కలర్ acidic medium, yellow కలర్ basic medium. అది all the 3 ions ని detect చేయగలదు. When you talk about phenolphthalein, this indicator can detect the presence of only strongly basic ions like OH minus and carbonate. Okay, the pH range is 8.2 to 10. It is colorless in acidic medium and pink color in basic medium. That's the initiation for the experiment. Okay, so next I'll have to say about the presence of ions. So I'll go to the next point. So next point I need to know is about finding the concentration of these ions. So the next point which I have to check is the test sample can contain how many types of ions? How many types of ions is the next discussion. ఎందుకు ఇక్కడ రావట్లే? How many types of ions? అంటే what I am asking, whether in a particular experiment I am finding the concentration of only OH minus or only carbonate, only bicarbonate, or their combinations. The right answer is in a particular sample of water, okay, the combination of ions can be either OH minus, only bicarbonate, only carbonate, or only OH minus, or it can be OH minus and carbonate, or carbonate bicarbonate. But all the 3 ions cannot be present. Okay, so the test sample contain how many types of ions, how many combinations of ions? How many combinations? Combinations of ions. Now from here, I want you to be little alert. Okay, first point is all the 3 ions cannot be present in the same solution. all the three ions cannot be present in the same solution. Why? Because you take a right leg. OH minus ion and bicarbonate ion, if they are present in the same solution, will quickly react to form H2O and carbon dioxide. Will form H2O and carbon dioxide. Therefore, the possibility of three ions existing together is ruled out. Okay. Why? Because OH minus and bicarbonate ions combine to form water and carbon dioxide. Therefore, this option is ruled out. Okay. The next option. So, the second point I should know is the five combinations possible. The five combinations of ions are the five combinations of anions. The five combination of anions which can be present in the test sample are which can be present in test sample are okay, the five types of anions which can be five combinations of anions which can be present in this test sample are okay, are I am writing okay at the top. So what are the five combinations that are possible? Are you able to understand? The first combination is only bicarbonate. Only bicarbonate. Second one is only OH minus. The third option is only carbonate, CO3 2 minus. Okay. The fourth option is OH minus and CO3 2 minus. Okay. And the fifth one is CO3 2 minus and HCO3 minus. Okay. Are the three combinations that are possible. Okay. So everyone just listen to this point clearly. What I was trying to tell you all that now I understood that I am doing an acid-base titration in which the test sample, that is alkaline water, is base, and I'll react it with an acid whose concentration I already know. Okay. And one more point I know is that in this titration, for a single titration, I'll use two indicators simultaneously. Means one after the other, I'll be using the two indicators. One is methyl orange, the other one is phenolphthalein. Okay. I also understood that why I'm using two indicators is because I have to identify the concentration of these ions individually. Okay. So what I know that methyl orange is one indicator which can find the concentration of all the three anions, that is OH minus, bicarbonate and bicarbonate. Whereas the phenolphthalein indicator is one which cannot detect bicarbonate ion at all. That means if you are adding to this phenolphthalein indicator to a solution which is containing only bicarbonate, it will not show any color change. Okay. And it can detect only OH minus and carbonate. Okay, so that is fine. After that, I have to come to next one more important point. What? Will the test sample contain single ions or combination of ions? Then the answer is, first point I know is that the possibility of finding all the three anions at a single time is not possible. Why? Because OH minus and bicarbonate ions quickly react to form H2O and carbon dioxide. So, finding OH minus and bicarbonate ions in the same sample is ruled out. Then I am left with only 5 combinations of the ions. What are the 5 combinations of ions? Either single ions like carbonate, OH minus or bicarbonate present, or the combination of ions is OH minus carbonate, carbonate and bicarbonate are the only 5 combinations that are possible uh, in a test water sample. That's the conclusion I make. Okay, and after this, I want to start doing my experiment. Okay, so just like any experiment, I told you. Okay, this experiment also has 3 steps. Okay, before I start noting down the steps of the experiment, I'll first have to know about the neutralization of these ions. As I told with you, now I am reacting these ions with an acid like sulfuric acid or HCl. In any of these cases, acid provides only H plus ions. So the important thing, we can put a star mark there. Into the right level. Okay. So you can put the star mark and write. The important reactions which I need to tell you is about neutralization of the 3 anions. So what's the next one? Neutralization of 3 anions. Neutralization of the 3 anions during the experiment. Okay. So what is the first one is the test solution. If it has this anion CO3 minus, it reacts with 1H plus ion, which is from acid. This is from the test water sample, to form what it will form? H2O plus carbon dioxide. Okay, that is the neutralization reaction of carbonate ion. The second anion that neutralizes is OH minus. It reacts with the H plus ion to form H2O. The third ion that undergoes neutralization is carbonate, CO3 2 minus. And it is important to understand that carbonate neutralization takes place in 2 steps. In step 1, it reacts with H plus ion to form HCO3 minus. Okay, this is step 1. Okay, step 1. Okay, whereas this bicarbonate ion further reacts with H plus ion to form H2O and carbon dioxide. This reacts with H plus ion once again to form H2O and carbon dioxide. Now this is step 2 of neutralization. Okay. Now at this point, I need to tell you, all of you, that when I am writing all these things on the board, okay, what I'm trying to teach you all is that When bicarbonate ion is present, can I use methyl orange indicator or not? Can I use methyl orange indicator?
Yes, ma'am.
Sumit? Okay. So I can use methyl orange indicator. Can I use phenolphthalein indicator?
No, ma'am.
No. Why? Phenolphthalein cannot detect the presence of a weak basic ion like HCO3 minus. Now, if I am taking OH minus, can I use phenolphthalein indicator?
Yes, ma'am.
Yes. Can I use methyl orange indicator?
Yes, ma'am.
Yes. Is she right? Hello? Rest all in the class. Please do not feel sleepy.
But it will get converted into HCO3 minus.
No, listen to me. నేను OH minus గురించి అడుగుతున్నా. Will it will it show color change for methyl orange? Yes. Phenolphthalein also yes. Okay. If you understand this, you will enjoy what all I'm saying. If not, you'll feel bored. Okay. Rahman, did you get it? You have not answered. You understood? Okay. Now the next one, Vaishnavi and Harshita. I think you are answering. Okay. Next, how about carbonate? Can I use phenolphthalein and methyl orange? Yes. This carbonate ion can also be identified with both methyl orange and phenolphthalein. But if I'm using methyl orange, fine. Everything from first to the last, the methyl orange indicator shows the color change. But if I'm using phenolphthalein indicator, in this case, what will happen? Carbonate, till it time it gets converted to bicarbonate, that phenolphthalein indicator shows the color. When soon it gets converted to bicarbonate, it will no more show any color change till the end point. Now at this point, I have to add methyl orange indicator. Okay, and do the titration. Okay, it means what? If I want to find the total alkalinity, I can use methyl orange indicator. Why I'm using a combination of methyl orange and phenolphthalein, both the indicators is to find the individual concentrations of these anions. Okay, and hence is the usage of two indicators for the same titration. ఏం చెప్పాను అర్థమైందా? ఎందుకు రెండు రెండు ఇండికేటర్స్ ఒకటే టైట్రేషన్ లో వాడుతున్నాను? వై ఐఎమ్ యూజింగ్? ఎందుకు అంటే ఈ మూడు anions OH మైనస్, కార్బనేట్ అండ్ బైకార్బనేట్, ఈ మూడు anions కి మిథైల్ ఆరెంజ్ ఒకటేసారి వేసేసి టైట్రేట్ చేస్తే ఫస్ట్ ఏ కలర్ ఉంటుంది చెప్పండి? నో ఇఫ్ యూ టెల్ దిస్ I'll be actually very happy. I've taken the test water in the conical flask and I've added methyl orange indicator. Okay, what should be the color of the indicator? You need to tell me now. ఏ కలర్ ఉంటుంది చెప్పండి ఇండికేటర్? టెస్ట్ వాటర్ శాంపుల్ యాసిడా బేసా? Test water is acid or base? What? You should tell me. Is it an acid or a base? Come on, kids. Come on, you are already in the class. Don't feel lazy. Should tell me. The test water sample is an acid or a base? Tell me. When you say, not Harshita, tell me, when you say water is alkaline, which due to presence of which ions?
H plus ions.
ఆల్కలైన్ అంటే H ప్లస్ ఏంటమ్మా?
ఆల్కలైన్ అంటే OH మైనస్.
ఏదో ఇది కాకపోతే అది, అది కాకపోతే ఇది.
నేను యాసిడ్ అని విన్నాను.
ఇప్పుడు నీ టెస్ట్ వాటర్ శాంపుల్ యాసిడా బేసా?
Base, ma'am.
Is she correct, Usha?
Yes, ma'am.
Yes, sir. How about Rahman?
Yes, ma'am.
Is it a base? Huh?
Yes, ma'am.
Or how about Akshaya? Akshaya?
Yes, ma'am. Yes, ma'am.
Acid or base or test solution?
Base.
Base. No, Shashank. ఇక్కడ నుంచి యాసిడ్ వచ్చింది. శశాంక్ ఆర్ యు దేర్? వాడు ఆన్ చేసి వెళ్ళిపోయాడా? సోమేష్ మౌనవ్రతం ఏంటి? వాట్ సాయి, యూ డిడ్ంట్ ఓపెన్ యువర్ అకౌంట్ టుడే?
లేదు.
వినట్లేదా? ఏంటంటే క్లాస్ ఆఫ్టర్ క్లాస్ చెప్తోంది ఇవిడని. నేనే చెప్తున్నానంటే నువ్వు ఈజీగా వినగలవని అర్థం అక్కడ.
వింటున్నా మ్యామ్. కొంచెం నెట్ ప్రాబ్లం ఉంది మ్యామ్, ఒక్కోసారి బ్రేక్ అవుతుంది వాయిస్ అందుకు.
సరే, ఇప్పుడు H+ion ఎక్కడి నుంచి వచ్చింది? నేను తీసుకున్నాను అండ్ ఇట్స్ కాన్సంట్రేషన్ ఇస్ ఆల్రెడీ నోన్. ఓకే, నౌ ఎవ్రీ వన్ ఆఫ్ యూ హ్యావ్ అండర్స్టూడ్ దట్ the test water sample is alkaline in nature. So if I add methyl orange indicator to that particular test sample, what will be the color of the indicator? Please tell me quickly so that I'll finish at the earliest. Cheppandi, what's the color of the methyl orange indicator in basic medium? Did I give dot points? Andike istanu.
Yellow.
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 Yellow. So as soon as I add methyl orange indicator, the color will be yellow. Okay, so I'll take the conical flask, I'll pipette out some 20 or 50 ml of that test water sample and I'll add 2 drops of indicator. That solution will be yellow in color. Now I'll fill the burette with HCl solution or sulfuric acid solution. Then I'll start doing the titration. Okay, now if I start doing the titration, at the end point, what will be the color of the solution? Red color. Fine. Over. There is no possibility of all these 3 anions present. So whatever the anion that would have been present would have reacted to give the product. Okay, and the alkalinity that I'll find by using only methyl orange indicator is total alkalinity. Now, why I'm using combination of methyl orange and phenolphthalein is what we are going to learn right now. A very interesting thing. Okay, so is the discussion. So what is the next point you should write here is, if only methyl orange indicator is used, if only methyl orange indicator is used, then it gives total alkalinity. That's an important viva voce question, generally asked. It gives total alkalinity. Okay, next point which I should tell you all is combination of methyl orange and phenolphthalein indicators. Combination of methyl orange and phenolphthalein indicators for the same titration helps to find the concentration of individual ions. Concentration of individual ions. That's the key point of this experiment. Okay, so this is very important. All these are viva voce questions, whatever I'm writing on the board. Okay. Okay, next. Next point is, hope you have written this. Now let me quickly go ahead. Now, what will write? This experiment has 3 steps. Experiment has 3 steps. First one is preparation of standard solution, standardization of acid solution, that is HCl, and finding the concentration of alkaline test water sample. Okay. So experiment. What is the experiment? Finding the aim is to find the alkalinity of water. To find the alkalinity of water. To find alkalinity of water. What is the chemicals? What are the chemicals required? Chemicals are alkaline test water sample, alkaline test water sample. Okay. Then you'll have dilute HCl. You'll say it as link solution, methyl orange and phenolphthalein indicators. Methyl orange and phenolphthalein indicators. Okay, are the chemicals I'll use. Okay, next, important is principle. Principle is alkalinity causing. Principle is alkalinity causing OH minus, carbonate and bicarbonate ions. Alkalinity causing OH minus, carbonate and bicarbonate ions are estimated by reacting with standardized acid, taking phenolphthalein and methyl orange indicators. Using phenolphthalein and methyl orange indicators. Okay, that's the principle. Now, the procedure. Now, procedure has 3 steps. Procedure has 3 steps. Okay. Now, if you write the experiment like this, easy. Okay, what is the first step? Step 1 is preparation of standard solution. Standard solution. And in this experiment, you'll prepare sodium Na2CO3, sodium carbonate standard solution. And you'll prepare sodium carbonate standard solution in this experiment. Okay. The next one you will do, second step is, this is step 1. Step 2 is standardization of dilute HCl solution. which is nothing but the link solution. I'll give the definition what it means by standard solution and link solution at the end. Okay. The step 2 is standardization of dilute HCl solution, which is the link solution. And step 3 is estimation of alkalinity. Estimation of alkalinity of the test water sample. These are the 3 steps of the experiment. So what's the aim of the experiment? To find the alkalinity of water. The chemicals required are alkaline test water sample. Then you'll have dilute HCl, which is used to react with the test water sample to find the concentration of the ions present. Then I'll use 2 indicators, methyl orange and phenolphthalein. The principle is to find the concentration by reacting the sample with the acid, whose concentration you already know. And in this experiment, I'll use the 2 indicators. Methyl orange gives the total alkalinity, whereas the combination of phenolphthalein and methyl orange indicators will help in finding the individual concentrations of the anions that are present. Okay, and the experiment has 3 steps. Step 1 is preparation of standard sodium carbonate solution, then finding the concentration of HCl link solution, and third step is estimation of the alkalinity of the sample. What I want to tell you here is, once again, that is it possible that all the 3 anions could be present? No. So possibility of finding the 3 anions is not there. So the 5 combinations which I have are only carbonate, only bicarbonate, only hydroxide, or the combinations of OH minus, carbonate, carbonate, and bicarbonate. Now, how to detect the combination? Okay. Right. Step 3. Finding the alkalinity, estimating the alkalinity of test solution. Step 3, estimating the alkalinity of test solution. Now it is question time to test your logic. Okay, so please feel free and alert to ask doubts and answer my questions. Okay, so I am finding the concentration of the test water sample. So to find the concentration of all the ions, I'll simply take the methyl orange indicator and I'll do the titration, which gives total alkalinity. No, my idea is not that. To find the individual concentrations. So, first thing is, in step 3, okay, I have to find the concentration of the ions. Fine. So what I'll do, I'll draw a crude diagram here. Okay, and I'll start the explanation. So in this experiment, what I'll do, I'll take the burette, okay, and I'll fill the burette with dilute HCl. Okay, so the burette contains dilute HCl. Fine. Then I'll take a conical flask and I'll take, in that conical flask, some 50 or 100 ml my test water sample, and I'll start using the indicators. What I should always do is 100 ml of test water and indicator. So what you should remember here is always, first I will add phenolphthalein indicator. First, I'll add phenolphthalein indicator. Then I have a question. If I use phenolphthalein indicator, what is the color of the solution? Took the test water sample in the conical flask and I added 2 drops of phenolphthalein indicator. What will be the color of the solution? What are the 2 colors with respect to phenolphthalein indicator? Hello? What are the 2 colors with respect to phenolphthalein indicator? What is the
Pink,
color of phenolphthalein
colorless.
indicator?
Colorless, acidic, pink, basic.
Basic.
అంటే ఇప్పుడు if after upon taking 100 ml water and adding indicator to my test water sample, the solution is colorless or pink in color. Chapandi, what is the color? The test water sample is alkaline or acidic?
Pink color.
Huh? Pink color. Is she correct?
Yes, ma'am.
Yes. Pink color is correct. Why? This water is alkaline in nature because phenolphthalein indicator is pink in color. As a basic medium. The solution is initially pink in color. Okay. After that, what I'll do? I'll dropwise add HCl into the reaction medium. Okay. I'll dropwise add this HCl to the reaction medium. Okay. At the end point, what should be the color? Initially, it is pink in color. At the end point of the titration, what should be the color?
Colorless.
Colorless. Okay. So, initially, it is pink in color. On adding HCl, the solution turns colorless. Okay. Now, say some V1 ml of HCl got consumed. Okay. When the color of the phenolphthalein changed from pink to colorless. Okay. So V1 ml of acid which got consumed is taken and I'll say it as phenolphthalein endpoint. Okay. And చెప్పా టెస్ట్ వాటర్ శాంపిల్ ని కొనికల్ లో తీసుకుని ఫినాఫ్థలిన్ ఇండికేటర్ యాడ్ చేస్తే బేసిక్ కాబట్టి పింక్ కలర్ ఉంటుంది. హెచ్సిఎల్ డ్రాప్ వైజ్ యాడ్ చేసుకుంటూ వెళ్ళి ఇలా స్టర్ చేస్తూ ఉంటే ఏమవుతుంది? సొల్యూషన్ యాసిడిక్ మీడియం అవుతూనే కలర్లెస్ అయిపోతుంది. అప్పుడు ఇక్కడ ఆపేసి నేనేం చేస్తాను? బ్యూరెట్ లో రీడింగ్ చూస్తాను. ఓకే. రీడింగ్ చూస్తే సమ్ 0 ml నుంచి ఎంతో సమ్ 20 ml 30 ml 40 ml ఎంతో కొంత హెచ్సిఎల్ కన్జ్యూమ్ అయింది. ఓకే. ఆ హెచ్సిఎల్ ఏదైతే కన్జ్యూమ్ అయిందో దానిని V1 ml అని రాస్తాం. ఓకే. విచ్ ఇస్ నథింగ్ బట్ phenolphthalein endpoint. What is phenolphthalein endpoint? The HCl which got consumed for the color change of the indicator from pink to colorless. So, I'll say V1 ml is equal to amount of HCl consumed for the neutralization from pink to colorless, color change of phenolphthalein. ఇది రాస్తే ఎక్కువ ఉంది కానీ చెప్పడం ఈజీ. అంటే ఫినాఫ్థలిన్ పింక్ నుంచి కలర్లెస్ అయ్యేటప్పుడు ఎంత హెచ్సిఎల్ కన్స్యూమ్ అయిందో దానిని V1 ml కింద రాస్తాం. దీనిని it is called phenolphthalein endpoint. Phenolphthalein endpoint. It shows phenolphthalein endpoint. Okay, that's the first point. What's the second point? Now from here I'll not throw the solution. I'll take the same old solution to the desk. Now I'll add methyl orange indicator. Okay, to this colorless solution I'll add methyl orange indicator. What should be the color of the indicator? Yellow or red? Hello, please, are you listening? If you listen this, you'll enjoy. Or if you understand this, nothing like that. But I want to finish it quickly. Because I don't want to take much of your time, but it is very interesting and important as well. ఇప్పుడు చెప్పండి, పింక్ కలర్ నుంచి కలర్లెస్ అయిన సొల్యూషన్ ని పారపోయకుండా వెళ్ళి మిథైల్ ఆరెంజ్ ఇండికేటర్ యాడ్ చేశాను. నౌ the test water sample is acidic in nature or still basic in nature? It will be still basic in nature. Okay, and it will take yellow color indicating the alkalinity of the sample. Why? Why is because the test water sample might contain bicarbonate ion, or if the test water sample contains carbonate ion, it will be converted to only bicarbonate till the solution turns to colorless. There still it has the bicarbonate ions which give yellow color upon adding methyl orange. So when methyl orange is added to this sample, again it will give yellow color. I'll further continue the titration till the color changes to red. Okay, and I'll take the volume till that point, till the color changes from yellow to red as V2 ml. Okay, I'll take that volume from where methyl orange indicator showed the color change from yellow to red as V2 ml. So what is V2 ml? V2 ml is equal to the volume amount of HCl required for the neutralization of bicarbonate ion in the sample. Okay, what is V2 ml? The amount of HCl required for the neutralization of bicarbonate ions in the sample. Why? If the test water sample already has bicarbonate, then also it will get neutralized only when methyl orange is added. If carbonate is present, from here to here the carbonate might have formed bicarbonate. From here onwards the bicarbonate got neutralized. So V2 ml is the HCl which got consumed for the reaction of H plus with the carbonate. Okay, and did you all write this? And capital M is equal to methyl orange endpoint. Capital M is methyl orange endpoint. Which is sum of V1 plus V2 ml. Enduku? Had you added methyl orange in the beginning of the titration, it would have been yellow in color and got converted to red color. Okay, so methyl orange endpoint is a sum of V1 ml plus V2 ml. Okay, did you write that? If you understand this, I'll finish the explanation very, very easily. If you don't get it, then I'll be in a fix. Why? To make you understand the combination, it will take time. Anyone having doubts, please raise your hands. Don't feel hesitant. Did every one of you understand? ఏంటి దీక్షిత, కార్తీక్, సుమిత్, మీ అందరికి అర్థమైందా? నిఖిత, శృతి, ప్రజ్ఞ, కీర్తి, రేమాన్, వేణు ఆన్ చేసి వెళ్ళిపోయారా? ఏం నీరజ్?
Yes, ma'am. I'm there. Yes, ma'am.
There? Where there?
In class, ma'am. At that time, I went to outside, ma'am. My father called, so I went, ma'am.
ఓ నాయన, ఏమిటి నేను ఇంపార్టెంట్ చెప్పినప్పుడు నువ్వు వెళ్ళిపోయావేమో బయటికి, చూసుకో.
Just 5 minutes, ma'am. That's it. I came back.
ఓకే, సరే. ఇప్పుడు నీకు ఇవన్నీ అర్థమయ్యాయా?
Yeah, ma'am.
వైష్ణవి, శేఖర్.
ఎస్ మ్యామ్.
ఓకే, ఇప్పుడు నేను క్వశ్చన్స్ అడుగుతా, మీరు ఆన్సర్ చెప్పాలి, లేకపోతే నేను చాలా ఫీల్ అవ్వాల్సి వస్తుంది. ఎందుకు? ఇట్ ఈస్ ఇంట్రెస్టింగ్ ఇఫ్ యూ అండర్స్టాండ్ ద టాపిక్ బై ఆన్సరింగ్ క్వశ్చన్స్. ఇఫ్ నాట్, ఇట్స్ అ లౌజీ టాపిక్. సరే, నౌ ఐ హ్యావ్ టు చెక్ ద కాంబినేషన్ ఆఫ్ ions. ఓకే, what are the 5 combinations? Individual, each of these ions, OH minus carbonate, bicarbonate and carbonate are the combinations. Okay, now I have my issue. Now tell me, I took some 100 ml test water sample in the conical flask. First, which indicator I'll use? I'll use phenolphthalein indicator. The phenolphthalein indicator should show pink color, but it did not show any color. It was colorless. Which is the combination that is present? Think and tell. Anybody? Now I've started doing the experiment. Okay, then I took the sample and I added what? First thing what I did, I added phenolphthalein indicator. Okay, the phenolphthalein indicator actually should show pink color, but instead it didn't show any color. It remained colorless. So what is the combination that might be present? Aha, perfect online class. నేనే క్వశ్చన్, నేనే ఆన్సర్, నేనే ఎస్, నేనేను. ఏదో క్లాస్కి రావడమే ఎక్కువ అంటే ఇప్పుడు మళ్ళా క్వశ్చన్స్ అన్నట్టు మీ ఫేస్. చెప్పండి. ఇలా ఇంటరాక్ట్ చేయకపోతే చాలా టెన్షన్ వస్తుంది నాకు. కలర్లెస్ ఉంది అంటే what is the ion which can't be detected by phenolphthalein indicator?
Bicarbonate.
Bicarbonate, correct? Okay, so if I'm talking the first combination, if V1 ml is equal to 0, V1 ml is equal to 0, the first option, are you able to see the board? If V1 ml is equal to 0, then phenolphthalein is also 0 because phenolphthalein didn't show any pink color. Okay, then the combination is only bicarbonate. Okay, only bicarbonate present. Okay, then V2 ml is equal to M. ఎందుకు M is equal to V1 plus V2. Okay, therefore V2 ml is equal to M. So if methyl orange is the only indicator which is showing color, okay, and phenolphthalein absolutely does not give the pink color, then the test sample has only OH minus. Okay, so did you understand the first option? Only OH minus. Then I'll do the calculations. Now, in the next experiment, what I did, as usual, I prepared out some 50 ml test sample and I added the first indicator, the phenolphthalein indicator. It gave pink color. So what are the two possibilities that might be present in the test water sample? Answer the question. ఏం చేశాను? phenolphthalein indicator first యాడ్ చేశాను. పింక్ కలర్ ఇవ్వకపోతే ఓన్లీ బైకార్బోనేట్ ఉందని. సో phenolphthalein indicator ఫస్ట్ యాడ్ చేస్తూనే అది పింక్ కలర్ ఇచ్చింది. సో వాట్ ఆర్ ద టూ possible anions that might be present? What kids? You are not liking this session?
OH minus, CO3 minus 2.
Is she correct? How many of you support her? Hello? You're not understanding. It's interesting. Just put your brain. Feel tired. See, if you don't understand, it means it is equal to not attending the class. Is she correct here? Is your friend correct? Usha is correct? Tell me. What? Sujit? Roll number 117. Good evening.
Good evening, ma'am.
117 is Vaishnavi.
Yes, ma'am.
18 is Sujita.
Yes,
Sorry.
ma'am.
Vaishnavi, is your friend correct?
Yes, ma'am.
It is as if I am extracting water using bore. Okay, this is the combination. So if the phenolphthalein indicator is giving color, then the answer is both OH minus and bicarbonates are present. Fine. No, but the discussion is not that. I'll start doing the titration and I'll come to the point that when the titration is over, the solution turned colorless, and now I take the same solution to the desk. I added methyl orange indicator. The methyl orange indicator gave red color. So what is the anion that might be present? ఏం చేసా? HCl యాడ్ చేసి ఎప్పుడైతే సొల్యూషన్ పింక్ నుంచి కలర్లెస్ అయిపోయిందో అప్పుడు ఆపేసి టైట్రేషన్ ఈ మొత్తం వాల్యూమ్ ని V1 ml కింద రాసుకుని మళ్ళా డెస్క్ దగ్గరికి వెళ్ళి దాంట్లో మిథైల్ ఆరెంజ్ ఇండికేటర్ యాడ్ చేశాను. ఓకే, మిథైల్ ఆరెంజ్ ఇండికేటర్ రెడ్ కలర్ ఇచ్చింది. వాట్ మైట్ బి ద anion present or anions present?
Bicarbonate.
Bicarbonate. Is she right or wrong? Is she right or wrong? Why bicarbonate?
Methyl orange detects bicarbonate.
But methyl orange gives yellow color in the presence of bicarbonate. It gave straight away red color. That is end point color. What it shows? Bicarbonate is absent. Okay. So, had the solution got OH minus and carbonate, then the carbonate should have got converted to bicarbonate, and that bicarbonate that's present should have given yellow color with methyl orange. Now, because there is no bicarbonate, it straight away gave the red color, the end point color with methyl orange, showing that only OH minus ion is present. అర్థమైందా? ఫస్ట్ స్టెప్ ఏం చేశాను, ఫినాఫ్థలిన్ ఇండికేటర్ అసలు కలరే ఇవ్వలేదు అనుకో, మిథైల్ ఆరెంజ్ ఇండికేటర్ కలర్ ఇస్తే ఓన్లీ బైకార్బోనేట్ ఉందని చెప్పాలి. ఓకే, ఆ ఆప్షన్ చాలా ఈజీ. ఇప్పుడు సెకండ్ ఆప్షన్ కి వచ్చా, ఫినాఫ్థలిన్ ఇండికేటర్ కలర్ ఇచ్చింది. ఏం కలర్ ఇచ్చింది? పింక్ కలర్ ఇచ్చింది. ఇప్పుడు మళ్ళీ యాసిడ్ తో న్యూట్రలైజ్ చేసినప్పుడు అది కలర్లెస్ ఫామ్ చేసింది. సరే, ఆ సొల్యూషన్ కలర్లెస్ అయిపోయిన వెంటనే నేను బ్యూరేట్ లో రీడింగ్ చూసుకుని ఎంత ఉంది, ఎంతో సమ్ V1 ml ఉంది బ్యూరేట్ రీడింగ్, అది రాసుకుని మళ్ళా వెళ్ళి డెస్క్ లో అదే సొల్యూషన్ కి మిథైల్ ఆరెంజ్ ఇండికేటర్ యాడ్ చేశాను. మిథైల్ ఆరెంజ్ ఇండికేటర్ ఎనీ బేసిక్ అయాన్ ఉంటే, అంటే బైకార్బోనేట్ ఇంకా ఎందుకు, OH మైనస్ కార్బోనేట్ ఫినాఫ్థలిన్ తో కలర్స్ ఇచ్చేస్తాయి. సో ఫినాఫ్థలిన్ కలర్లెస్ అయిపోయిన టైం కి ఎప్పుడు ఏం అయాన్ మిగులుతుంది అంటే ఓన్లీ బైకార్బోనేట్ అయాన్ మిగులుతుంది. ఆ బైకార్బోనేట్ అయాన్ సొల్యూషన్ లో ఒరిజినల్ గా ఉండొచ్చు, లేదా కార్బోనేట్ బైకార్బోనేట్ దాకా కన్వర్ట్ అయ్యి ఆగచ్చు. సరే, అప్పుడు ఆ బైకార్బోనేట్ అయాన్ ఉండడం వలన అది ఎల్లో కలర్ ఇస్తుంది. ఆ ఎల్లో కలర్ టైట్రేషన్ ఎంటర్ కి రెడ్ కలర్ ఇస్తుంది. అమ్మా, ఇప్పుడు ఏమైంది, ఇప్పుడు సెకండ్ స్టెప్ నేను చేసినప్పుడు ఫస్ట్ ఫినాఫ్థలిన్ కలర్ ఇచ్చింది. సో నేను అనుకున్నాను అయితే OH మైనస్ ఉండొచ్చు లేదా కార్బోనేట్ ఉండొచ్చు అని. అయితే కార్బోనేట్ ఉందనుకో, ఇప్పుడు అదేమవుతుంది, ఫినాఫ్థలిన్ కలర్లెస్ అయ్యేసరికి ఇది కలర్ బైకార్బోనేట్ కింద కన్వర్ట్ అయిపోతుంది. సరే, ఆ ఉన్న బైకార్బోనేట్ అయాన్ ఇప్పుడు ఏం చేస్తుంది, మిథైల్ ఆరెంజ్ ఎల్లో కలర్ ఇస్తుంది. అలా కాకుండా డైరెక్ట్ రెడ్ కలర్ ఇచ్చేసింది అంటే ఓన్లీ OH మైనస్ ఉందన్నమాట. Therefore, if I think this is because of that. If ఇది కూడా అయిపోయిందా, if V1 ml is P, if P is equal to V1 ml, my God, what is this? Because of that spray. If, oh my God, okay. If V1 ml is equal to no problem, I'll write in a book. Just excuse me. So now if V1 ml is equal to P, okay, and there is no V2 ml because methyl orange didn't show any color, then obviously M is equal to P. What does it mean? అంటే మిథైల్ ఆరెంజ్ చేసినా ఫినాఫ్థలిన్ వేసినా సేమ్ యాంటీటైటర్ వాల్యూ. ఓకే, సో వాట్ ఈస్ ద కాంబినేషన్? ఓన్లీ OH minus ion is present. What's the answer? Only OH minus ion is present. You understood? Okay. If only OH minus ion is present, it gives color with the phenolphthalein, but methyl orange does not show any sort of color change. Okay. So that's the discussion. Fine. Next. What's the next one? I can say, fine. Okay, right. If one second, I'll set and I'll get back. Okay, if only carbonate is present, if only carbonate is present, then now tell me. Hello. If only carbonate is present, then tell me, as soon as I add phenolphthalein indicator, does it give color or not? Are you listening? If only phenolphthalein indicator is added, does it give color or not? What? Are you listening? If only phenolphthalein indicator, does phenolphthalein give color if only carbonate is present? Are you there, kids?
Yes, ma'am.
ఏంటి ఆన్సర్ చెప్పట్లేదు మీరు అందరూ? I asked you a question. Does the test solution give color for phenolphthalein indicator if it contains only OH minus ion? I'm sorry, carbonate ion. See, still my session is not over. Only that the markers are not writing. That's it. Better buy a stand like this. That will be easy. Okay. So, if only carbonate is present. Okay. So, what will happen if only carbonate is present? Tell me. Okay. Initially, I'll take my conical flask. Okay. This conical flask, I've added the test sample and I added phenolphthalein indicator. Does the carbonate ion give color with phenolphthalein indicator? Hello. Does phenolphthalein indicator give color with carbonate ion? Come on, kids, quickly. If you don't answer this, you'll feel bored. I'm telling you, I want to finish. 4:10, 4:15, I have started class. It is 5:40. Now I should finish now. You want it only in the explanatory mode, then I will tell. But you will not use your brain. Okay. Then, phenolphthalein initially will be pink in color. Upon titration, it turns white, colorless. Okay. The volume that got consumed is V1 ml. Okay. Now, at this point, I go to the test and again add methyl orange indicator to the colorless solution. The solution turns pink in color. No, sorry, yellow in color. The yellow color turns red, and if I write down the titer value, it will be V2 ml. So, both V1 and V2 ml are present for this titration. Okay. So, what will happen if V1 ml is equal to V2 ml? Ante, నువ్వు ఫస్ట్ ఫినాఫ్థలిన్ యాడ్ చేసి పింక్ కలర్ నుంచి కలర్లెస్ అయినప్పుడు సమ్ 10 ml ఉందనుకో, మళ్ళా అక్కడ ఎల్లో కలర్ మిథైల్ ఆరెంజ్ వేసినప్పుడు వస్తే దానిని నువ్వు రెడ్ వచ్చేదాకా టైట్రేట్ చేసావనుకో దానిని V2 ml కింద రాశారు. If V1 ml is exactly equal to V2 ml, then what? Then only carbonate ion is present. Why? In the first step, carbonate got neutralized to bicarbonate, and at that point the solution turned colorless, and to that colorless solution, as soon as you added methyl orange, it turned yellow and it turned to red at the end of the titration. What you realized that this is equal to this. This is 10 ml, this is 10 ml, this is 8 ml, this is 8 ml. So if V1 is equal to V2 ml, then carbonate is present. Okay. For bicarbonate, V2 ml is 0. Okay. For V2 ml is present, V1 ml is 0. If OH minus is there, only OH minus, V1 ml is present, V2 ml is 0. But for only carbonate, both V1 and V2 ml both are present. Okay. Now, in this case, what you should write? If V1 ml is always equal to P, that is phenolphthalein endpoint. But I know methyl orange is nothing but V1 plus V2. Okay. So, can I write M is equal to 2P? Okay. So, if only carbonate is present, M is equal to 2P. This is important. That's how you will detect the presence of only carbonate in the test water sample. You understood? Okay. Then I'll go to the next combination. What is the next combination? Presence of OH minus and carbonate. Okay. The fourth option is presence of OH minus and carbonate. Okay. Because OH minus and carbonate both are strongly alkaline, they give pink color with the test solution. Upon titration, okay, the color changes to colorless. I'll write that as V1 ml. V1 ml, which is equal to P. To the colorless solution, I'll add methyl orange indicator. Okay. And what I will find? That methyl orange gives yellow color and it gives red color upon titration. Okay. So, the color change from yellow to red is V2 ml, which shows the neutralization of bicarbonate ion. Okay. What you will understand here is that this bicarbonate that is formed is not originally present in the solution. Okay. It came from the carbonate which got half neutralized till the solution turned colorless, or when methyl orange showed yellow color. Okay. Now, what is your expectation? V1 ml will be more than V2 ml or V2 ml will be less than V1 ml? What is your expectation? Come on, girls and boys. Tell me, what is your expectation? V1 ml will be more or less than V2 ml?
V1 will be more.
V1 will be more than V2. That's option which Harshita gave. Who will say yes to that answer? It is correct. Very good. V1 ml will be more than V2 ml. So, by chance, if your titration is showing V1 ml more than V2 ml, then you can guess the presence of OH minus and carbonate. Okay. Now, this is fine. How to find the individual concentrations of OH minus and carbonate? Okay. Now, can I write M is equal to V1 plus V2? Okay. M is equal to V1 plus V2 ml. P is equal to V1 ml. And can I write that P is greater than half m. Why? If V1 is equal to V2, M is equal to 2P. Okay. Now M is actually a measure of the total alkalinity. Fine. Now, if P is taken, P is always now, because V1 ml is greater than V2 ml, P will be greater than half M. Okay. This is what is the supposition. Now, how to find the concentration of only OH minus ion? So, how to find the concentration of OH minus ion? For that, I'll have to know the amount of acid which got consumed for carbonate. Why it is easy? See, in the first step, when the acid was getting consumed with phenolphthalein indicator, both OH minus and carbonate ions were getting neutralized. Okay. And when the solution turned colorless, OH minus got completely neutralized, whereas the carbonate got half neutralized. Okay. So in the second step, when I added methyl orange indicator, which gave yellow color, it was just showing the half neutralization of carbonate. That is, neutralization of bicarbonate formed from the carbonate, giving red color. Okay. So first, if I calculate the concentration of carbonate, that is easy. So V2 ml, which I got, is all due to the presence of bicarbonate ions, which I got from the carbonate ion. Okay. So if V2 ml is exactly what I got, so 2 into V2 will be the complete neutralization of carbonate. Correct? Am I correct? Hope you are able to understand. Fine. Then carbonate will be, V2 ml will be what? I know that V1 ml is nothing but P. Okay. M is nothing but V1 plus V2. This is what I wrote here. V1 plus V2 will be M and P is equal to V1 ml. Then if I know that the total volume is M, okay, you're able to understand. Hope you're able to understand. See, the total volume is M. Okay, total volume is M. Till this point I have P. Okay, so this volume will be M minus P. Okay, this volume will be M minus P, which is nothing but V2 ml. You want me to repeat? Please tell me. Hello? Please tell me. My topic is over. In another 3 minutes time, it will be over. The only thing is, you should understand. What, Usha? You are not answering means you are not able to understand. Correct? Okay. First titration చేసేద్దాం. ఓకే, టైట్రేషన్ చేసినప్పుడు ఫినాఫ్థలిన్ కలర్ ఇచ్చింది. ఓకే, అది పింక్ కలర్. when it turned to colorless, ఎంత యాసిడ్ కన్స్యూమ్ అయింది? V1 ml of acid కన్స్యూమ్ అయింది. ఓకే, అది ఫినాఫ్థలిన్ ఎండ్ పాయింట్. నెక్స్ట్ ఆ సొల్యూషన్, కలర్లెస్ సొల్యూషన్ కి వాట్ I added methyl orange. Okay, that was yellow in color and it converted to red color. Okay, ఆ మిథైల్ ఆరెంజ్ ఎల్లో నుంచి రెడ్ కన్జంప్షన్ అయింది, మొత్తం V2 ml కింద తీసుకున్నాం. సరే, ఇప్పుడు డిస్కషన్ ఏంటి? V1 ml V2 ml కన్నా ఎక్కువ ఉంది. ఓకే, సో V1 ml ఈజ్ మోర్ దాన్ V2 ml. ఎప్పుడైతే ఆ కాంబినేషన్ వచ్చింది అనుకో, V1 ml ఈజ్ ఈక్వల్ టు V2 ml, ఏంటి? ఈజీ. ఫినాఫ్థలిన్ కలర్ ఇచ్చింది అనుకో, అప్పుడు ఏముండొచ్చు? 2 ions ఇక్కడ, OH మైనస్ కార్బనేట్. సరే, ఇప్పుడు ఎప్పుడైతే ఫినాఫ్థలిన్ కలర్లెస్ అయిపోయిందో అప్పటికి కంప్లీట్ OH న్యూట్రలైజ్ అయిపోతుంది. బట్ కార్బనేట్ కాస్త ఓన్లీ బైకార్బనేట్ కన్వర్ట్ అవుతుంది, హాఫ్ కన్వర్ట్ అయింది. సరే, ఇప్పుడు బైకార్బోనేట్ ఏదైతే ఫామ్ అయిందో అది V2ml ఆఫ్ యాసిడ్ తో రియాక్ట్ చేసి అక్కడ న్యూట్రలైజ్ అయింది. సో ఈ సెకండ్ పార్ట్ లో ఏది న్యూట్రలైజ్ అయింది? బైకార్బోనేట్ దట్ గాట్ ఫార్మ్డ్ ఫ్రమ్ కార్బోనేట్ గాట్ న్యూట్రలైజ్డ్. సరే, సో ఈ టోటల్ వాల్యూమ్ ని V1 ప్లస్ V2ml ని M అని అనుకుంటున్నా. అప్పుడు ఇది P, టోటల్ వాల్యూమ్ M, V2ml ఏమవుతుంది? M మైనస్ P అవుతుంది. సరే, మీరు ఏం గుర్తుపెట్టుకోవాలి? ఎప్పుడు V1 ఈస్ గ్రేటర్ దెన్ V2ml అయింది అనుకో ప్రతిసారి, అప్పుడు ఏం కాంబినేషన్ ఆఫ్ అయాన్స్ ఉన్నాయి? OH మైనస్ అండ్ కార్బనేట్ అని కన్సిడర్ చేయాలి. ఈ కాంబినేషన్ లో ఏమర్థమైంది? V1 is equal to P, V2 is equal to M minus P, and total volume which is V1 plus V2 is M. సరే, సో ఇప్పుడు ఇండివిజువల్ కాన్సన్ట్రేషన్స్ కనుక్కునేటప్పుడు OH మైనస్ ఫస్ట్ కనుక్కోవచ్చు, కానీ కార్బనేట్ తో మొదలు పెడుతున్నా ఎందుకంటే దట్ ఈస్ ఈజీ. ఎందుకు? ఈ సెకండ్ స్టెప్ లో ఈ టూ కాంబినేషన్స్ లో సెకండ్ స్టెప్ లో ఇన్ ద సెకండ్ స్టెప్ which got neutralized? Only bicarbonate that formed from the carbonate in the first step got neutralized. Okay, so if M minus P is the volume that got consumed here, for the complete neutralization of carbonate, can it be 2 into M minus P? Can it be 2 into M minus P? Correct? Am I correct? Easy? Okay. So this is 2 into M minus P. This portion is M minus P. And here again M minus P might have got reacted to complete neutralize this carbonate ion. Now how about this OH minus? Here how many ions got neutralized? One was OH minus, the other one was carbonate to bicarbonate. Okay. So P has two combinations. Full neutralization of OH minus, half neutralization of carbonate. So when I'm saying OH minus neutralization, then it is the total volume V1 is P, which is the total HCl got consumed for neutralization of both complete OH minus and half CO2 3 minus, CO3 2 minus. Okay, so how much this will consume? Only M minus P. So can I write P minus M minus P will be the amount of HCl required for neutralization of this OH minus? Okay, that will be equal to 2P minus M. So for the complete neutralization of OH minus, I need 2P minus M amount of HCl, and for carbonate it is 2 into M minus P. Okay, this combination is possible when V1ml is more than V2ml. When V1ml is more than V2ml, this option is possible. Okay, in this case, P is greater than half M. If V1ml is greater than V2ml, P is half more than M. So P is greater than half M. And the amount of carbonate requiring HCl is 2 into M minus P. And OH is P minus M minus P. That will be equal to P minus M. Okay. The last option that is left is combination of carbonate and bicarbonate. Okay, if the solution has carbonate and bicarbonate. Okay, so if the solution has carbonate and bicarbonate, okay, will it give color with phenolphthalein? Yes, it gives color with phenolphthalein because of presence of carbonate. So I have started the titration. So what we will realize that when initially phenolphthalein got added, it shows the neutralization of carbonate to bicarbonate. Okay, it shows the neutralization from carbonate to bicarbonate. So the area or HCl till the solution turned pink to colorless, I'll write it as V1 ml, which showed only carbonate getting converted to bicarbonate. Fine. Now, after this point, I'll take the colorless solution, add 1 drop of methyl orange indicator. It gave yellow color and then it started consuming HCl and the end point color was red, and I'll take it as V2 ml. Now I know that V1 is equal to V is equal to P, which is phenolphthalein endpoint, and V2 ml is what showing the neutralization of carbonate that was initially present plus the bicarbonate that was initially present and the bicarbonate from the carbonate. Total, I'll take it as M. Okay, and V2 ml is more than V1 ml. Okay, if V2 ml is more than V1 ml, the combination is carbonate and bicarbonate. That means P is less than half M. If V2 ml is greater than V1 ml, P2 is less than half M. Okay, I know in the first step, when V1 ml got consumed, okay, so it was P. So complete neutralization of carbonate here requires how much? 2P. 2P, correct? And when I'm talking about the amount of HCl that got consumed in V2 ml, then it is only with respect to carbonate, bicarbonate. So in this second case, in V2 ml, bicarbonate that was half converted from carbonate and the bicarbonate that was initially present are there. Okay, I know that the carbonate in the second step required only P amount of HCl. Okay, and the total is M. Okay, so if total is M, in that P if I remove, I'll get bicarbonate concentration. Okay, this is how I can find the concentration of bicarbonate. Why? Total is M. This portion is M minus, this portion is M minus P, and here P. The carbonate is 2P. Okay, and here M minus 2P, na? M minus 2P is correct. M minus 2P is bicarbonate. Okay, and hence is the discussion. Okay, fine. This concludes the table for calculation of amount of HCl required for neutralization. Right. The amount of HCl required for neutralization, amount of HCl required for neutralization of ions. Okay, neutralization of ions. Write this. Important. This is important. First, write this table straight away. Alkalinity, OH minus, alkalinity, OH minus, carbonate and bicarbonate. This is the table. Okay. And one numerical, I'll stop. Did you take it? Okay. No, the notes are there. So calculations, formulae for calculations. Formulae for calculations. Okay. Did you write it? Now, kids. Right? Drawbacks of highly alkaline water. Drawbacks of highly alkaline water, important. Most of the notes doesn't give this. First one, causes boiler corrosion. Causes boiler corrosion called caustic embrittlement. Causes boiler corrosion called caustic embrittlement. Next. Next. Leads to leaching of ions. Leads to leaching of ions in groundwaters. Leads to leaching of ions in groundwaters in contact with ore. Leads to leaching of ions. Leads to leaching of ions in groundwater in contact with ore. In contact with ore. That is what exactly is the problem. Next, leads to sludge formation in tubes or pipes. Leads to sludge formation in pipes or tubes. Pipes or tubes. Okay. Now, that finishes the alkalinity of water. I'm not very happy because I'm not, there is some sense in my heart which tells you didn't catch up, but there's no option. I'll have to conclude with 1 or 2 numericals quickly. It's more than, I should say, 2 hours, and I should finish this. This numericals, why I'm focusing is, understand. See, you will get some question and they'll ask this numerical. Some that 3 plus 4 combination, in which that 4 marks you might be knowing confidently, but these 3 marks numericals you are not able to solve. And I'll feel very sorry. And these are very easy to do because you're BTech students. I might feel is a little hesitant, but you will do it confidently. So I want you to really focus on the numericals. Okay. Now please take down this numerical and you'll understand. Okay. Let me get a thing.